Hello, my name is Alex Gonzalez. I am recording a series of coding algorithms that I've been working with. Right now, today I'm going to be working with double linked lists, and I already have a skeleton here. Before I begin showing how to code all of this, I'm going to share a little bit about me. If you go to Google and you search for Kozlex, Kozlex, you're gonna find all my social networks, LinkedIn, Facebook, Instagram, or anything that it's over there. Personal blog post, or even technical blog is over there. My personal website, which is alexgonzalez.life, and so much more. Okay, so that's a brief introduction. Let's start with what's the skeleton of the program. So to save some time, I already pre-created one skeleton of what's going to be the main functions that I'm going to be implementing. So the main structure that I'm going to use is struct node, which has a value and also has a pointer to the next element and a pointer to the previous element. The operations that I'm going to be implemented is to create a random list with a particular number of elements. I'm going to print the list, I'm going to free the memory of that list, then I'm going to insert a node, and then I'm going to remove a node. Those are going to be the operations. Before I go to the main, I'm going to tell you that also, to save some time, all those operations have their functions definitions over here. With the parameters that are going to be useful. The parameters that are going to be using is to create lists is the number of elements and the address of the first element of the list. In the previous video of single linked lists, I named it head, but now I'm going to just name it first just to make sure that we understand a little bit more where we are in regards to the pointers. In the print list, I'm not going to use the address, so I'm just going to print things. On the free list, since I'm going to free everything, I don't need to return any value of any pointer. I did it in the single linked lists, but not now, not anymore. As well, in the insert node, I'm going to pass a value so we can create the node inside of the function. And I'm guessing I'm going to use the address because it might get into the first element when we are inserting a value. We can try that. So if it's in the first position, then we need to update the address of the first element, of course. And to remove node, same case, right? We might remove the first, so the first element, so the pointer to the first node needs to be updated. So let me just update this here to remember that I'm going to do this. Okay, so what I have here is the main function. I already defined or declared the struct node that's going to be first, and it's immediately going to null. If you saw my previous video, you noticed that I was struggling with some trash in memory because I didn't initialize it at null. So I'm doing it now. And then I'm going to create 10 elements, a list of 10 elements. I'm going to print the list, passing the first element. And I'm going to later free the list, passing as well the first element. And I'm going to free all the list. I'm not going to try to keep anything there. So let's start. To create the list, since I'm passing the number of elements, I'm going to create a loop for, let's say, int I equals to 0 for e less than non-lms e++. So here I'm gonna be creating struct node, a new node that is gonna be allocating some memory And then as a best practice, immediately we're gonna initialize the next pointer to null, as well as the new node previous to null. And since we're populating the values, let's do the val. Again, as in single linked lists, I'm gonna use I plus 2. That's gonna help me to insert later something in the middle that is not a pair number. So now that I have my first new node, I need to update probably the head if the head pointer is null. So if first, first, not head, first is equal to null, then it means that this is the first element, right? So we need to say that first is equal to new node. That's it. That's what I'm going to start doing in the first element. Now, if it is not the first element, let's say it's the second, we need to make sure that we are going to update the correct indexes. So first, I'm going to declare struct node and index equals to null, actually to the first element. And since we're just creating a new list, I'm gonna position the index in the last element of the list. So I'm gonna do it. I like to do it through a for index, not index next, not equal to null, then index equals to index next. With this, I'm going to move the element to the last element of the queue. For example, if index at the beginning it's pointing to the head, to the first element, so we know that the first element next is null, so it's not gonna iterate at not a single time here. So index is gonna stay in the head. So what I can do now is to say that my index well, actually, I need to check if index is equal to the head, because if that is the case, I'm not going to update anything that is before the index, because there is nothing. Previous or pref has nothing. The previous pointer has nothing. So I cannot treat the first element as this in the same way than the next elements, second from the second to the end of the list. So what I'm going to do is to say that index, so fill next, it's equal to new node. So it's pointing my first element, which is the index element, to the new node, and the new node previous is equal to index. That's only for the first case. So I'm updating both, and then index next is not pointing to null anymore, and it's linking the new element, and the new element has knowledge about the previous element, which is index. And that's it. The new node next is already pointing to null, as you can see here, and the next element, I'm sorry, the index element or index node, it's already pointing to null as it was decided over here. But if it's the second or the third element, we need to do some other operations. For example, we need to update more pointers, such as if I am in the third, for example, my index is in the third element, it needs to index next, it's equal to new node, but I cannot do it yet because I'm first index next pref, it's equal to new node. So the fourth element is now pointing to the new node. So the third element should go to point to new node. Yeah. And new node, actually over here, new node next should be indexed next, and that's linking the fourth element to the new node in both ways. But I'm missing one, which is the new node pref is equals to the index, the current index. So I'm updating the previous from the next of the index in the first line. The index next to the new node, and then from the new node, the next and the pref are updated as well with the next is gonna be the index next and the previous is. So the thing is that this operation, that this is the fourth line in these changes, need to be last, because if we try to do it first, we're gonna lose the pointer to the next. Let's say index next is working over here. Now let me think for a second, because I'm trying to figure out and understand if this might cause problem, and I think it will, because if the next one is null, then I'm gonna point to my index. Let's say that it's the last element of the list. This means that this, and usually we're gonna get there, but this is gonna point to a next, and next is gonna be null, and null is gonna be pointing to pref, and that's gonna be a problem. So this should be the case where it's in the middle. So what we need to do is to add another condition, and let this case be the last handling case. Now, in case we're pointing to the last element. Or last node. I say element and node and vice versa, but you know what I mean. As a comment in the first position, inserting and here okay, we're good there. So in case if it is the last node and the index is in the last node, then we're gonna say that we haven't created the condition. If index next equals to null, it means that there's nothing left in the list, so we're pointing to the last node. That means that we just need to say that the new node pointing previous equals to index, and the index, the current one, next is going to point to new node, right? So we're just updating two elements because there's nothing at the end. We're already at the end, and then there's not any pointer else to add. Or yeah, well, there's null, so we cannot do anything there. Let me think really quick here. So the new node next, I'm not talking about this previous, I'm talking about the next. It's already pointing to null, so the list, as we can see here, so the list is ending in null as expected, right? And the index previous still doing what it does. If it is a list of 100 elements, the number 99th element is going to be pointed by index previous, and that's fine. So that's it. So that's the way we create 10 elements. I'm just saying 10 elements because that's what I sent as parameter. And I don't think to return anything. If you see, the only thing that changes is the first element that was passed by address. So that's okay. I don't need to update anything else, and that will be it, in my opinion. So to free the list, I'm passing the first element. As well, I'm going to need pointer, an index that starts in the first element, and probably I'm going to need a temporal element that also gets into the first. Well, it doesn't really matter. I think this is going to be null because I'm not going to use a previous element. I'm just going to move ahead, and if I free something, I'm going to move to the next one based on the temp, and that's it. So for index not equal to null, basically I'm saying everything delete index it's equal to index next. What I'm gonna do here is to make TMP equal to index next. If it's null, it's fine, because what I'm gonna do here, it's free index, but I already have the next element in index, so I'm gonna say index equals to TMP, and whatever, if it had a null, sure, we're at the end of the queue, and if not, then no. So the only thing that is going to be weird, well, I'm going to finish this here, but I'm already moving the TMP to the next, and I'm already moving as well here this, so I don't need this because I'm moving it here, and I'm doing the free over here. So just to make sure that we're doing things right, I'm going to print f the free of this particular value index val, just to list that I'm doing the free of everything. I think that's it. I had something else that I was thinking about here. Oh, I was about to say that the only thing weird is that first here is passed by as the pointer. There is not an address that we're passing, so the first variable is not going to be updated on the main function. And that's somehow okay because the free is the last operation, and as soon as we finish, the variable is gone and we don't need it anymore. Probably some cases, let me think, what's more convenient. There is no way to hijack something at this kind of 20, maybe 10 lines of assembler or something that can affect. I mean, there's not vulnerability, there's not risk. This just gonna have a value that is gonna be trash. Oh, and talking about trash, when we're doing the free, or before doing the free, and to make sure that everything is fine with when we're returning anything from that address, and I mean, we're not returning anything, but to make sure that everything is gonna be safe, well, let's do the index, the initialization of the pointers to null, because we're gonna free them anyway. Yeah, hope that makes more sense. And as I said in the previous video as well, why not do the val equals to 0, so there is not any value that might be compromised in memory once the memory is not used, and any other process might take advantage of it for security purposes. And that would be it. That would be the free of this. In the print, let's do it now. It's going to be very similar, struct node, but we're not going to use a temp because we're not going to move things around. We're just going to traverse the list and then print things from the list. So for index not equal to null, index equals to index next, and just let's print f let's print the value of index val, and let's do a print f of let's put some values that are going to be in the should I just type it anyway, just to have a nice format when we're printing things. So I'm doing the free, I'm doing the print. Am I missing anything here? I'm not. Index not equal to null. Once it's null, that's it. Let's print things. I'm missing a semicolon over here. Oh, yeah, it's VI. No problems with semicolons over here. I don't see anything that's missing something like that. Let's try it out and see what surprises do we have. I have the create 10 numbers, print. I have commented out the other operations that we're gonna do in a second, but the free list is there. So, my file is named double linked list dot double L. I'm just gonna do that. So in the number 46, I have an error line 46, and that's if index equals to head. Of course, there is no head. And then 69, okay. Struct node index first. Oh, I should not do this because it's not an address. And 86, it's gonna be similar, I guess. Yes. Okay, so let's execute double L and ta-da. Yeah, sure, why not? Segmentation fault. Let's see where am I doing something wrong. What I'm gonna do, this is gonna be, well, I'm gonna spend some memory. I have so much memory. I'm gonna see if the problem is on create list. And yes, it is there. So when I'm creating the list, seems like I'm gonna need to print some things here to make sure that I'm getting to the right places. First, if I'm lucky, I'm gonna find this soon, and sure, why not? First, it's gonna be there. Usually I have the problem when I'm moving the index. So index, let's do this, index. I'm just gonna add some validations to make sure that I'm not index. Sure, why not? Let's just add some validations first. Double linked lists. Okay, so it's getting nowhere. Okay, I got double linked list at least there. Okay, so just to try to isolate the problem, I'm gonna change the else to here. Oh, probably it's here. Yeah. Okay, first it's getting there, and it seems to be a healthy memory address, which is fine. So the problem is in the next part. So, yeah, let's keep it there. Yeah. So the 4 didn't go anywhere. Let's see here. Seems to be okay till there. I guess it's gonna be the previous cells. Oh, yeah, it's gonna be here. If index next is equal to null, and okay, I'm gonna validate that. Probably I'm getting into something. Okay, it helped me to the segmentation fault. Okay, there's no more segmentation fault. There's nothing. There's one element that says 0, and the 0 is the first element, which means that this is not taking me anywhere. So let's see the value of index, or where is this value getting from? Wait a minute. Okay, so it seems that I'm printing the value of index here, okay, but this is causing a segmentation fault, which means that I need to validate that. Okay. Oh, come on. Oh. Okay, I'm not even getting here, which means that I'm always getting into a null. So since I'm printing, this is getting into the null. So index next equal to null. I'm going to move it to the next element. So it seems like I just got okay. I'm moving the index till there is not an element. To the next, to the end of the. To the end. Whoa. Okay, I got distracted for a second. Okay. The index on the second iteration okay. I'm doing this. I didn't update the index that is going to be now in the first element. So I'm never going to move because it was null. Yeah, I forgot this part. Let's see. Yeah, so we have elements from 10 elements from 0 to the 18th. So that's good. That's pretty good. Yeah, this was my mistake. I didn't update the index, so the first time the first pointer was null and index was null, so it was never coming anywhere here. So the create list worked perfectly. The print list worked perfectly. So now let's uncomment the free list. Yeah, so we're doing the free for from 0 to 18th, which is good. Okay, so let's clean up a little bit the printfs. I don't need this. I need this, I need this, I need this, I need this. That's it. Okay, so now I'm gonna implement the insert node that it's gonna insert a node with value number 5, and I'm passing the first, but I need to pass the address of this. I don't need to just do that. And actually for the remove as well, I'm gonna be passing at some point the address, as I already had specified here. Because when I insert node, maybe it's gonna be in the first position. So, ta-da, here, insert node. Pretty sure that I'm gonna use struct node index equals to first. There. And since I'm using a new val, I'm gonna use struct node, new node, equals to memory allocation, size of struct node, and new node equals next equals to null, new node previous equals to null, and new node val equals to val. So we have the value there. Okay, so we have this. So if we need to search for a position where to insert, and in this case we're going to do, since we have an ordered list, and this is the case that we're working with an ordered list, let's add it in before or according to the ordering that we already have. So the first scenario is going to be if index, well, actually I need to position the index somewhere. Index is less than val, index val, yeah, index, next, I'm thinking just mixing things and then writing everything around. So with this conditional, what I'm doing is iterating till the val, or till the val is less than the val. So if I have a 8th here and my thing is interesting. So this is what I'm going to do. This is going to be a 6, for example, or 7, and let's use that as an example. If I'm going to insert a 7, or what am I inserting? A 5? A 5. So I'm inserting a 5. So I'm inserting a 5, and this is a 6. 6, it's lower or less than 5. That is true. But in this case, you're going to notice that I'm way ahead of that. But I can go back. I have a pointer to the one in the previous. So I'm going to validate that I'm not going too far first to a null. So if I guess I can move, and this is a similar case than single linked list, but I'm trying to figure out if there is an easier way with double linked lists to position the pointer. And I don't want to use a previous because I already have a pointer to the back. So I'm gonna say if it's a 6, if index If it is not null, because it's not, then I can say that I can move the index one place back, like index. I'm just trying to do an experiment. Expriv, and that takes me. I don't need that because if index is valid and I'm doing this, means that I'm not yet at the last position. So means that I can just point to the previous, and yeah. So index is in the 6th, but I want to do, yeah, I need to do an else before this, and I'm gonna get there in a second, but I'm gonna try to finish this. So this is gonna be kind of in the middle case. This is what I'm thinking. It might get into the middle, insert in the middle. So that case, index previews next equals to new node, index previous is equals to new node as well, and then new node. Oh, I lost it. Be careful with the pointers, that's what I say. Next, it's supposed to be the index, right? Index. Oh, actually, I still have it. It's there. The index has not changed. The pointer has not changed position. But new node previous should be the index previous. But the previous is already pointing to the new node. So you can see why it cannot go here, because I should go to the new node previous should go to the index previous, but we lost it. This is already pointing to somewhere else. So solution is simple. New node previous equals to new node, new index. Let's review this. So my index is in the middle, and there's supposed to be, there's not, yeah, but in this case there's going to be one in before. So we have a previous, and we are not going to have a segmentation fault because previous exists. And this means that the previous next is going to be pointing to the new node, and then the new node previous is going to go to index, which still exists, but the index preview is going to go to the new node, because remember the index right now is one position ahead of where we want to do it, and the new node next is going to be the one that is after the position we want to do. So this should work. And let me think about this again. Index previous next is going to be the new node. Yeah, that's fine. Now we're assuming that there is a previous here. So in order to make sure that this is valid, we need to do something here before. So if we're in the first position, let's say that the index equals to first, then we need to do something here. In this case, this is the insert beginning. If it didn't move, then it's because it was not less than, which means it's equal or so. So we just put it in the left, and we are going to change the first. So at some point first, it's equal to new node position. New node next. it's equal to index that is pointing to the very first element of the list, and then index previous is equal to new node, and that's it. That should do the magic. We don't need to update the index next. It doesn't matter if it's null or not. And the new node previous, we don't need to do anything because now it becomes the first in the list. Now, what if it's in the last of the list? If it's in the last of the list, this is going to cause a segmentation fault. So we need to make sure that else if here as well, else, this is going to be just an else. Let's do validation of the element. That's it. I mean, it should be there, but that's fine. So if it's the last element, that means how can we get here? Let's think about this for the for. It's gonna break if it's null. I think this can take us to the first element. It can take us to an element in the middle, but it can take us as well. Yeah. So if index and index next it's equal to null, means that it's the last element, then what I'm gonna do is to so it should go to the last. I think it's gonna be, if its index next is equal to null, it's because we're in the last element, but the last element, it might go to the, if index is equal to null, if we had it to the very last element, because we got into here, means that we never gonna reach the last element. We cannot compare. If it's the last element and the index is in the last element, then it's gonna come here. But the condition here should be about the index val, I think, because if let's say we insert a number 250 and the last element is 18. 18 is less than 20, the answer than 5, and then 50. The answer is yes. So it's gonna move to the last one, and then it's gonna become null, and that's it. We're not gonna do more. So when we can compare by the value, if index equals to null, means we reached the last of the last. We reach the last, then inserting the last. I think that's the case. If we reach null, because it's gonna reach null, if index val question. If index, it might be the case where index next is null, which means we ended up in the last element. If index, but what if it's the last of the last? I think we need another case. Interesting. I'm trying to make this a little bit efficient, but figuring out that this might change, but I don't know. But I want. Yeah, it works in the middle. Yeah, this if this is the last, it's gonna work in the middle. But if it is 20, yeah, 20. Yeah, 20 less than 30, yeah, it's gonna be null. But if we reach null, I don't have any pointer to the previous. So what do I do? It's gonna head to the last. So I'm gonna do something here. I'm gonna add a conditional. This is gonna assure that I never get to null, which means I can add here if val is greater than index val, then insert the last. And also index next it's equal to null. I also need to validate that index exists. I mean, it should exist because I'm validating that it never gets to null, but that's fine. So here, if it's in the last, I'm going to say that index next it's equal to new node, and new node prev it's equal to index, and that will be it, I think. So I'm going to insert a 5. So if it is a 5, I'm going to come here, the next is not null. 5 is less than 6, the answer is no, so that it stays, 6 is lower than 5, the answer is no, so it's going to stay in the 6th, index is no, index next it's equal to null, no, so it's going to come, index exists, yes it exists, index previous, and it does the magic to insert the number 5, and the 5 should be inserted. I don't need this. And now, yeah, if I insert a 0, the next is different than null, yes. Index val is 0 lower than 0, no. So it's going to stay in the index in the first are going to stay the same. And then it said, so what if it's the 18th, for example? It's indexed next different to null. When it gets to null, no. So the index is going to stay at the very end. It's not first. Index exists. Index next is equal to null, yes. And the val is greater than no. Greater than or equal, because I'm talking about 18th. Then I'm gonna insert it in the last. So I guess it's gonna work. Let's see. Okay. 114. Oh. Okay. So we were looking to insert a 5. Ooh, it worked. That's a charm. It's pretty cool. So let's try to insert another one. Let's say the insert node. Let's try the 0, which is the one in the beginning. Just to try it out. Okay. What did I do? Oh. Well, yeah, we have 2 zeros over here. Great. Now insert node to, let's do the 18th and then the 20. And first, yoo-hoo, the 18 is at the very end. That's pretty cool. I'm so excited. And the 20 is there. Woo, wow. Yeah, minimum errors. Perfect. So and I'm looking into the free. So the print is okay, but I mean the free is more it's better. So let's move the element 12 just to say to the 12. Let's create the code to remove something, and it's the remove. Yeah, well, strict node. Asterisk index. It's equal to first element. So we're gonna search for index and index val. It's equal to val. Once we get there, so we're gonna look for the value that is passed as parameter into the values of the list. Once we found it, if index means that we found it, if we didn't find it, we reached the end of the list. We're gonna, we need to see if it's the first element. If index equals to first, then at the beginning so I'm gonna use a temporal. Should I? Let me think. I'm gonna remove the first. Yeah, I'm gonna use temporal just to not mess with things. Okay, so first thing that I'm gonna do is that the first, I'm gonna move it to the index next. Now, TMP, actually I don't need the TMP because the first already moved. So index is in the first element, so free index, and then index equals. That's it. I don't need to do anything else. First, I was planning to update index into the first, but there is no meaning. I'm not gonna use index anymore. But I do need it here, of course. And that's it. Now this is the case where, remember at the beginning. Let's see. Else, if we're in the very last element, let's say if index next null it's equal to yeah, I'm thinking about if there is one single element, this is going to point the first to null, and that's fine because we're going to have a null list. That's fine. If first index next equals to null, then I'm in the last element, so index I'm supposed to be at least in the second element in this case because it was not the first. So if I am in the second, I can make a reference to the previous. So if index previous is equal to null, right? And index, just to make sure that I'm gonna free something that it's there. So with this, I already detached the index from the list, which is good. And with this, I'm cleaning up the pointer. So free index, and that will be it. In the case it's in the last. But if it's in the middle, then I need to say that if I'm in the middle, then means that I have two on the side, so I can play with the pointers. I'm not in the last one, so I'm not gonna try to point to the next and cause a segmentation fault. So there's no need for an if. Means that index next pref is equal to index pref, whatever that is. If that's null, sure, because it's the first element, sure, why not? And then that I already updated the node in the right to point to the left. But if there is anything on the left, because there's supposed to be something, because it's not the first element as in the first conditional, then I can do index pref next. It's equal to index next, and that keeps things aligned. So index, I guess all these operations that I have here wait. Yeah, no, only this. Yeah. No, those are not the same. So index next, it's equal to null. Index pref, it's equal to null for security purposes. Free index. And that will be it. So let's 146, 146. Oh, what? Oh, something is missing here. Okay. I have my doubts right now, but yeah, the 12 is still there. I have my doubts. Am I removing the 12? Yeah. Okay, so the value is 12. Do we find it? Yes. Is it in the middle? Yes. So let's print something here. Move. Let's see, what do we have there? Oh, printf. He's not getting here. Okay, it's getting 0. But we're getting, of course we're getting, seems like we're not getting the pointer to the right place, and that's fine. Yeah, we're looking into, well, I want to show you, I'm looking into this. I'm supposed to be positioning the number 12, which is there, but I'm not getting there. So this index val 4. I'm moving from the first element, and I'm comparing if this is equal. They should take me. Index. Wow, let's see what's iterating. What's wrong with here? Huh. Wait, what? Looking at 0 because the index is not moving. Index exists, yes. Index val, it's equal to val. Oh, okay, I'm sorry. There we go. The 12 is not there anymore. So I guess that's it for now. Yeah, this was double linked lists, and those are my recommend. Oh, you want to try the? What if we remove the 0? But before doing that, let's not add it to this, so it gets the first one removed. Let's not add it. Oh. It says that it's trying to remove the 12. Oh, of course. Let's remove the 0. There it is. There's no more. I mean, it's not there. So there is no 0. And now let's try to remove the last one, which is the 20th. We added it, and now we're going to free it. Ta-da! It's not there. So, yeah, it found the 20, and that's it. So if you have any questions, you can find me on my Twitter @Kozlex, of course. Thank you so much, and see you in the next video.